Hello everyone, my name is Darren Lau and I'm the creator of SpectraAid. SpectraAid is a deep learning based app that helps people with color vision deficiencies, also known as colorblindness, to see colors in images more accurately and naturally. Now for some background, 1 in 12 men and 1 in 200 women have some sort of type of color blindness, which means that there's over 350 million people worldwide that have this condition. But there's actually three main types of color blindness. The first one is known as protanopia, which means that red, orange, and green tones are easily confused. And this is actually a type of color blindness that I have that inspired me to create SpectraAid. The second type is known as deuteranopia, which means that there's difficulty distinguishing greens from reds. And the last one is tritanopia, which results in confusion between blue and green, as well as between yellow and pink hues. Now, in order to actually test for color blindness, we use something known as the Ishihara plate test, and you can see one on your screen. What this means is that if you do not have color blindness, you should be able to see the number perfectly on the plate. In this case, the number 8. However, if you do have color blindness, such as red-green in this case, you either see the number 3 or nothing at all. And so for me, since I'm protanopia, a type of red-green colorblind, I do not see anything at all. But how does my app actually work? Well, it's based on a deep learning algorithm that I created. This AI algorithm learns how different types of color blindness affect color perceptions, and then it shifts the color gradient in a very specific manner. What I mean is that if you're colorblind, fundamentally you will not be able to understand or see certain colors. But even if two colors look the same to you, my AI can learn that and then shift those two colors in a way that causes them to have more contrast, essentially balancing the color blindness. And so users can take or upload photos and the AI will run in the background in order to alter those colors in a way that creates more contrast so that people with color blindness can actually see the colors in the image more accurately and more distinctly. And so the programming languages that I use to program this include HTML, CSS, and JavaScript to create the front end. And to create my deep learning algorithm, I use Python and PyTorch. And to actually load my deep learning algorithm onto the mobile versions of my app, I used React. And so let's head to a mobile demonstration of my app. So here I am on the homepage of SpectraAid. And if I scroll down, you can see all three types of color blindness. The first I'm going to start with is protanopia. And the first thing I'm going to do is actually upload a photo. So I'm going to navigate to my files, and I'm going to upload a photo of the Ishihara plate test. Now, this Ishihara plate test, if you are not colorblind, you should be able to see the 8 pretty well. But since I am protanopia colorblind, I cannot see the 8. But with the enhanced image, the deep learning algorithm has made it so I can see the 8 perfectly. And that's what this app does, is it enhances those contrasts. Now I'm going to go for a reset, and this time let me try out the tritanopia function, and I'm going to actually take my own photo as well. So here's a picture of Rubik's Cube in front of me. I'm going to capture that image, and now this is the original image I just took, but most importantly, you can see the enhanced image on the bottom. The deep learning algorithm has made it so that the greens are much more prominent, the reds might be a bit more muted, because it has learned how people with tritanopia see color and is adjusting accordingly. Finally, I'm going to try out the deuteranopia function, and once again, I'm going to upload a photo, navigate to files, and this time I'm going to select the image of the candies. You can see how the image of the candies might look a bit odd to someone that does not have color blindness, but the person that has deuteranopia, those colors have been shifted in ways that they can see the individual candies much more better, so it's not just like a mass of the same exact color. Thank you for listening, and I've had an amazing time being part of the Congressional App Challenge.